We have some situations where a connection needs to be shifted up to be covered or hidden for the architectural requirements, or because of the fire protection. In this case, we'll have to shift the custom steel bracket up, having a beam notch. We'll have the same maximum reaction force as we have on the previous, of course, and we'll have this verification with and without reinforcement. So first we'll try without reinforcement, and then we'll see if we need reinforcement. So we'll go back on the app, get back on the project level, and we'll add a beam notch calculator. So we have it in the Timberfair group. We can start editing. So in this case, we can firstly type in the appropriate properties of the beam. So we can select GL24C, 360 by 720. We have the support of the beams and columns. So we can have 200 by 200. If we go on the side view, we can check that's basically 80 millimeters on the side. We have the notch by 120, so we can have 580 millimeters here, I think. So we're going to have quite a notch. For this example, we have the notch distance and option for inclination as well. For the design methods, we have the Eurocode, we have the input forces, and we'll first try without reinforcement. So I'll set this for no. For design input, we'll select 108 kilonewtons, and for design data, we have the series classes, medium-term action, gamma amp can be on 1, and K6 on 1. So if we go on the shear check without reinforcement, we can see that it's on 109%. There is a warning that we need to provide reinforcement because the stress level are too high. So in this case, we can just select the screw reinforcement yes, and we have additional inputs in this case where we can select the appropriate fasteners. So for the screw supplier, in this case, we can try with Siga products. Again, more information is something that we can use all the time. So current alternatives and possibilities can be seen here. So in this case, I'll use fully threaded with cylindrical CAD. So I'll go with GoFix X Plus. So let's go with these products, and let's set some of the fully threaded screws. So I'll use 8 by 400 in this case. I can use the Siga ETAs. And for screw geometry, I'll just check in what are the requirements. So edge distance is on 40, numbers of screws are 3, and we have the embedded length of 50 millimeters, so it won't be visible from below. If we check the imagery, we can see the positioning of the screws compared to the supporting location. So on the side view, we can also see what are the positioning of the screws compared to the overall geometry of the beam and the notch. If we go on the results, we can see that there's still without reinforcement is just a reminder of that we need the reinforcement in this case. But if we go with reinforcement information, we can check the shear check at the notch area. We can see the reinforcement design and geometry check of the screws that we've been using. In the material properties, we can check the information about the beam that is being checked and the shear check. We have information about the without reinforcement and with reinforcement verifications, geometry check for the type of reinforcement screws we used, and the last part on the reinforcement design is how the tensile force is being taken to the screws and how that being verified. So according to ETA recommendations, we have information about the properties of the screws, and in the last part we have design actual capacity of the screws.